Hey guys, welcome back. This is Matt with Thrive Off Grid and Thrive Energy Systems. Alright guys, so we have the all-new DFX-S4 system. Alright, so this one here is going to Peru, and its application is to run two of the Duramax 9000, I think maybe they're 10,000 watt inverter generators. They're basically the same thing as the Predator 9,000 watt, or actually it's a 9500 inverter generator with the 457 cc engine. So just to show you how this is kind of set up, I run on our 8750, but ideally, well, if this were set up for the application, there would actually be two generators here. So we have a T here, and one would go to one generator, and then you'd use this attachment hose, and that would go to your second generator. Now, what's kind of cool about this, if you don't need to run full power, you can basically just shut one off. The intake and exhaust valve are never going to be open at the same time, so the engine basically is a valve. The only time that you could ever actually pull air back through is if somehow it landed perfectly on the decompression mode of the cam. There's a small lobe that decompresses the exhaust valve to make it easier to start, and then once your generator gets going, there's like a flyweight that pulls that back in. So the chances of that actually happening are pretty slim, but if it does, you just pull the cord over, and you'll get it off that decompression valve. But yeah, you can basically just run one or the other. You don't have to turn any valves or anything. It'll just be it'll be pretty much closed off, and then you can just run one side or the other. And then you just got a single air mix. So as I've demonstrated in our other video, once you get one going, then you can basically fire the other one up without doing any additional adjustments other than after the machine gets warmed up, which is typical even on a single engine setup. And then likewise, you can run one or both of these at the same time. So you got two valves. So right now they would be both online. And say if you didn't want to run both, then you can just basically shut one off and just run one. So now having these valves, the reason this is set up this way is so that you have refueling on the fly. Because if you have, say that's open, and then you open this hopper lid while the engines are running, you're going to give this an air blast, and that's going to change the gas energy density, and your static air mixer isn't going to work anymore. So your generators will basically just stall out. So to get around that, you just take the unit offline. Now you can open your hopper lid. Always stand back. Oh, Chris left the light in here. We had a small leak we had to repair earlier today, but we got that taken care of. But yeah, his battery's probably toast on this thing. But yeah, anyway, yeah, you're gonna want to stand back, make sure the gas can escape. You don't want to get blasted in the face. But yeah, you can go ahead and open this up, refill the machine, shut it back down, close the lid off, make sure it's sealed, and then just kind of slowly bring it back online, and then you can do the other one in the same fashion. Alright, so these are the DFX-4s. Now, what makes these different from the S3, so let me try to, those are S3s under the shelf there. So the S4 is quite a bit bigger. It's 6 inches taller than the S3 and 2 inches wider and 2 inches longer than the S3. So you're getting quite a bit more fuel capacity, and then you have the ability to jet this with 2 different jet systems. This has the small engine jets for running the 2 smaller generators. However, there is a large bore jet system that we offer for this, and that gives these machines quite an engine range that you can run. These machines can run between 300 cc all the way up to a 2-liter engine per machine. So these two here could run a 4-liter engine no problem. And if you add the third, which this is set up to run three you can team up the 3 gasifiers together. So we have this the main port blocked off, but we can add the port to this plate, and then you could actually have 3 units hooked up to this. So that would give you a total of 6 liters of engine displacement. So you could easily run a small block V8 with this system. Now another cool thing is you don't have to configure it this way. You could actually have one set up as an RTR. So that's how an RTR is set up, with a fusion bolted to the back, right? So you'd have one in the center set up as an RTR, and you can actually remove these side plates and the wheels, and you can bolt the modules to each side of the unit. So basically you could sandwich all 3 together, and then the 3 network together that way would fit in the back of a pickup truck. Let me find a tape measure. I'm pretty sure they're 14 inches. So that would be, see what, 28. Be like 44 inches wide if you had them bolted together that way. So that would easily fit in the back of even a small pickup truck. But small pickup truck, you probably only need 2, because they generally have a 4-cylinder or a 6-cylinder. So yeah, 2 would probably work just fine for that. So yeah, you could sandwich them all together in basically 1 unit. Now each unit is basically a giant hopper, as I just showed you. You know, this is all hopper space inside of here. So yeah, and you don't want to add height to this, because it just makes it more difficult to add fuel. You do have to service the machine. These are charcoal, so they do create clinkers, and down inside there, you know, if you get a clinker in front of that jet, you got to clean that out. So your arm is only so long, so we designed this specific so that you could reach down in there and service this. So yeah, and you don't want to. We're doing it the right way with adding the modules versus you know, adding on hopper and you know, hopper capacity by adding to the top. And you know, that also limits you, because when you add a module, you're adding another reactor. So you're not only adding fuel capacity, but you're also adding application size. So you know, if you had just 1 unit, you're still going to be stuck with the limitation of what that particular unit can run. So 2,000 or a 2-liter engine would be the max, versus if you add on the second module, now you run on the 4-liter instead of a 2-liter. So does that make sense, right? So yeah, you have a lot more versatility with this system. And besides, if we were to build another hopper, it's still a box, I'm still going to charge you just as much. You know, yeah, we add the wheels and the doors and the water tank and all that, but that stuff's pretty minor. We still have to figure out how to adapt it and make it airtight, and a lot of other dynamics to it's not quite that simple. Alright, so that is the DFX-S4. Yeah, so this thing is pretty versatile. You can run small generators on up to you know, a small block V8 powered pickup truck. Not saying that you can put it in a truck, but I'm just saying. We can't technically market this for vehicle applications. It's one thing if you adapt it yourself, but as far as us as a company, we can't market the system that way. So just making that clear. All right, I'm gonna show you some other stuff. We're working on the Gasifier. So we got the control box done, and alright, so this piece of hardware right here, this is going to be a standard controller, and it's going to be multi-purpose. So it's not only going to work for the Gasifier, but it's also going to work for the DFX Gasifier controls. Yeah, that was a lot of thinking to get this to where we could build this one way and make it work for two entirely different systems. Even though there's some things that are similar, but there's also other things that are not. So I've figured that out, and we're going to be able to outsource this. I don't want to get into doing wiring here in the shop. This generally requires a higher skill level, or it's more of a specialized skill set to wire and make it look pretty and all that. So that's something that I think will be difficult, and I have other people that can do that. All right, so I'm gonna go over this box real quick. You know, it's pretty. You know, it's very small, compact, and it's pretty low cost. These are just standard automotive cube relays. Although these are circuit protected, so these are a little more difficult to come by. However, this is dual circuit protected, so you have a primary fuse here. So even if you had to replace these, it's not you don't necessarily have to have the fuse protected relay. You can just get away with a a typical cube relay that you're gonna find at any automotive parts store like AutoZone, O'Reilly's, or whatever. These here are the temp probe amplifiers. Those we get on Amazon. They're about anywhere from 10 to 15 bucks. And then these here are sync type logic controlled MOSFETs, and you get about 10 of those for like $3 on Amazon. So you can order a lot of those, and those, if you ordered like 5 sets of them, that'll last you a lifetime. Plus we get it, they come 10 per set, so we give you the 2 as spares. And yeah, if one goes bad, you just unplug it and plug a new one in. It's as simple as that. And then of course the Arduino Nano, these are another low cost microcontroller. You get these on Amazon. They simply unplug. If you want to order backups, we can give you links. You can order like 5 of them for like 25 bucks, and then we'll give you the code and show you how to flash them so that you have spares. And then this here is just a 12 to 24 volt to 5 volt power converter, and them range anywhere from 10 to 15 bucks. This is very important to note, this is an 8 amp, so you want to make sure you're getting an 8 amp. Don't get any less than that, because especially on the DFX, because we're controlling a servo, and that's a bit power demanding on this, and you'll burn it up. So you want the 10 amp. Them are pretty bulletproof. The only thing that's really expensive are these, and these are Deutsch connectors. Deutsch are like one of the best connectors that you can get. Caterpillar uses them, Harley Davidson uses them. A lot of big companies use Deutsch, and for good reason, but it is expensive. Each one of these right here, they're 30 bucks. So I got $120 just in these parts. and that's not including all the connections at the applications on the machine. So like all the blowers, the valves, all those connectors, you know, they're about 15 bucks a piece. But you know, we use, Deutsch has a 360-degree crimp. They do sell these with the other style crimps, but the original has the barrel style, and they require a special crimper. I don't know if you can see this. But you can see that does a 360-degree crimp, so these crimps are good and solid. So that's why we're using those. So you know, you're not going to have any problems. So that's where I'm at with this controller. I got another box, an identical box to this one, on the way. It'll be here tomorrow, and that's for the 12-volt power supply, because this machine can run on DC or AC. Of course, to run on AC, you're going to want a converter. So we have the converter here. I have an off-grid system, so I'm always going to have AC power anyway. That's really the intent, is for this to keep the power on. So, but if the batteries died, you know, I could have a backup battery that I could run this directly off of 12 volts, and it'll work just fine. So we got that box coming for an enclosure for this guy, and then there's another power supply. That's a 12 volt to 48 volt DC buck converter. And that's to run the startup blower on 48 volt DC, and I'll show you that out here. So that's actually going to run on both DC and AC. So when we start the machine up, when we get this running and we're flaring the machine off, we want to run this at a lower volume, and that's so that we're going to it's going to supply gas to itself to fire itself back up. And we don't want to overwhelm that with too much air, because it'll just blow itself out and it'll never start. So we're going to run it at a lower speed, and then once we get it flared off, the temp probe up there will say, okay, we're ready to go, and then it'll switch the blower off, pause, and then it'll supply full 110 AC power to the blower, and these things will go full blast, and they'll charge the accumulators. Alright, so that concludes where I'm at for this week. Yeah, once I get that controller wrapped up tomorrow, when I get the enclosure, then it's a matter of wiring all the components up. And then once I'm there, and then we start writing code. So so that's it. Yeah, we'll probably be updating later next week with some updates on this, running the actual code. So yeah, we're moving right along, trying to get this thing to market. This year I'm hoping to have this on the market in beta format starting April, taking pre-orders for the June, possibly July. Probably I'm shooting for June for the first production run of the Gasifier. So we'll be taking pre-orders in April to start that, and then beta units will be offered for the rest of 2023, and then 2024 will be the actual production versions. If there isn't any changes, it'll probably be the same, but yeah, this here is the prototype. The production version coming out in June will be completely changed. It'll work the same and everything. The core is there, but I'm gonna do it a little different, and kind of try to clean this up, make it look a little better. There's some improvements we'll need to make it more manufacturable. This is kind of a good idea doing or actually I should reclaim that one. This is actually a bad idea doing this. It's too hard to get those angles correct all the time. So we're basically going to roll a reactor and then build some brackets that'll come off the side of there that'll bolt onto the reactor. and it'll look a lot better too. So yeah, again, anyways, that's where I'm at, and you know, thanks for watching. We'll see you next week. Thanks.